Hello everyone, welcome back to class of Harish Sir Physics. Now I'm going to start new chapter Gravitation. In this video, I'm going to discuss synopsis of gravitation, which will be useful to solve the problems in easy way. In this first one, universal law of gravitation, otherwise Newton's law of gravitation. Let us consider two masses, mass m1 and m2, mass m1 and m2. These two are separated by a distance of r. According to Newton's law of gravitation, the force is directly proportional to product of the two masses. Let us consider equation 1. And the force is inversely proportional to square of the distance between the two masses. Square of the distance between the two masses. Consider 2. From the equation 1 and 2, F is directly proportional to, can write m1 m2 divided by r square. F is equal to, this is a proportional constant. I'm going to write g into m1 m2 divided by r square. Here g is universal gravitational constant. Universal gravitational constant. Universal gravitational constant. The value of g is 6.67 into the value of g is equal to 6.67 into 10 power of minus 11 Newton meter square per kg square. Very, very most important dimensional formula of g value. So here g you can write F into r square divided by m1 m2. Force dimensional formula already we know, mlt power of minus 2. R is the distance, so L square divided by 2 masses, so m power of 2. You can write g is equal to m power of minus 1 L cube t power of minus 2. Next, superposition principle. Let us consider one system. The system contains number of masses. So this is the system. This system contains number of masses m1 and m2, m3 and m4. So many masses are there. So what about the force of mass m1 due to the remaining masses? So I need force F1. F1 bar is equal to, you can write F1 2 bar plus F21 F14 plus F13 bar. This is the resultant force on the mass m1. So F1 bar equal to, you can write in vector form, F1 bar plus F14 bar plus F13 bar you can write. Next one, acceleration due to gravity. So this is very, very most important. Most of the objective questions we are getting from this concept, acceleration due to gravity. Acceleration due to gravity. We know F is equal to G into M1 M2 divided by R square. I am taking M1 is equal to bigger mass capital M and M2 is equal to small m. You can consider. You can write F is equal to weight due to the weight. M into G is equal to G into capital M into small m divided by R square. Mass gets cancelled. You can write small g is equal to Gm divided by R square. So here G value vary depends on the situation. So generally G value at the poles will be greater than the G value at the equator. So that is the reason if we take any body from equator to the poles, the weight of the body will be increases because G value will be greater at the poles. Average, we will consider G value is most of the cases we will consider 9.8 meter per second square. Now, how this G value is going to vary? So G value is going to vary. G value will vary by the height and the depth. You can see here variation of G due to height, here variation of G due to depth. You can consider Earth as a spherical body. So this is the radius of the Earth. Suppose if you go height, some more height with the height h. So this is the point here. This is the point we are going to find. This is kept at a height of h. So generally you can write G is equal to Gm divided by R square. We can write. But due to the height h, so GH is equal to, you can write Gm divided by R plus H whole square. So you can keep 1 and this is 2. This is with the height. GH is equal to Gm divided by R plus H whole square. If you divide 2 by 1, GH by G is equal to, you will get Gm divided by R plus H whole square into R square divided by Gm. So this Gm gets cancelled. So GH by G is equal to, you can write R divided by R plus H whole square. Otherwise, suppose if the for smaller heights, you can write for smaller heights, H is less than R. You can write GH by G is equal to 1 minus 2H divided by R. GH by G is equal to 1 minus 2H divided by R. So this is the variation due to height. Now, how it is going to vary with the depth? With the depth, you can see here. Let us consider a spherical body. So assume this is as a Earth. So depth D. So this is the point depth D. So if we consider this is the depth D. From here to here is the radius. You can assume as a this is a small r is the radius. You can consider. So this mass of Earth. So if we consider we should consider the total radius r. So this, if you come to the depth D, so that means we should consider the radius r. So this radius r is the small r is equal to capital R minus D is the radius. So we know G is equal to total earth. GE is equal to G into ME divided by RE square we are writing. So density is equal to what we know? Density is equal to, we know, mass per volume. So mass equal to, you can write density into volume. So if you consider the total radius, total mass of the sphere, if you take 4/3 pi r cube, you can write. So GE is equal to G into total mass, you can write 4/3 pi r cube into rho divided by r square. So this square and this gets cancelled. We'll get G is equal to G Earth's 4/3 pi G rho R. Similarly, with the depth, if we consider, GD is equal to, with the depth, 4 third pi g rho. In the place of r, you can write r minus d. Here, g depth divided by g e is equal to, you can take 4 third pi g rho r minus d divided by 4 third pi g rho r. So everything is cancelled here. So remaining, so g d divided by g earth value with g is equal to r minus d by r. So we can write 1 minus d divided by r with the depth. So gd is equal to, you can write gd is equal to, you can write g into 1 minus d divided by r. Whereas if you consider with the height, we got gh is equal to, gh by g is equal to 1 minus 2h by r. This is for the smaller heights. So both are important here. Make it star for these two. Variation of g due to the rotation of the earth with the latitude. So first of all, what is the latitude? This is the center of earth, you can take. So center of earth is O, you can consider. You can draw any point on the sphere. So here I'm going to draw the point P. So here, if it makes an angle with the horizontal line, this is the horizontal line. If it makes an angle with the horizontal line, is said to be latitude. Here, so you can write latitude is angle lambda, you can write. So generally at the equator, it will be 0 degrees angle. If we take at the pole, that will be 90 degrees. Suppose if we take the resultant here, resultant component of force. So here we have to speak about the centripetal force. Centripetal force. So here I'm going to consider the resultant. So generally here, if you write, so this, let us consider this is the component. This is lambda, right? So if you take, so here is also make an angle of lambda. This will be f sine lambda. So this will be f cos lambda. Then resultant force, resultant force. Resultant force F is equal to, you can write mv square by r cos lambda. So here, so this will be upward mv square by r cos lambda. Generally way it will act downwards mg. So this is fr, you can consider. So fr plus mv square by r cos lambda, you can write mg. So then fr is equal to, you can write mg minus mv square by r cos lambda, you can write fr. Fr is equal to, so this is g is going to vary because of the rotation. So fr equal to, I'm writing m into g dash is equal to m into g minus mv square by r cos lambda. Then m gets cancelled. G dash is equal to what? You can write g minus v square by r cos lambda. When it is rotating, we know v is equal to r into omega, you can write. So if you write v is equal to r into omega here, g dash is equal to g minus v square. So r square omega square cos lambda divided by r, you can write. So here r, small r is equal to, you can write here cos lambda is equal to, you can write QP by RE. Then QP is equal to, you can write RE cos lambda. RE cos lambda. RE means capital R only. So you can write G dash is equal to G minus R square. In the place of R square, what we can write? R square, RE square. So this is V square by R, V square by R. R value we can write RE cos lambda we can write. So R square value we can write as capital RE square cos square lambda into omega square into cos lambda divided by R value. R value can write RE cos lambda. So this RE cos lambda and this RE cos lambda gets cancelled. You will get G dash is equal to G minus R omega square cos square lambda. Yeah, this is very most important formula. Otherwise, you can write G lambda is equal to G minus R omega square cos square lambda. I hope you liked it. Next part of gravitation I will discuss in my next video. Please comment if you need any topic. Thank you for patiently watching. Please like and subscribe my channel Harish Sir Physics for more videos. Thank you.